Very good morning to all. Welcome back to my course, Digital System Learning with Tinkercad Simulations. I am Dr. Syed Nagina Parveen, working as Associate Professor in the Departments of Electronics and Communication Engineering in SR University. Today's our topic is Universal Gates. Okay, so Universal Gates and designing of the basic gates using the Universal Gates. So firstly, I will give a brief introduction about these Universal Gates. Then we will we will have how to design using this Tinkercad simulation. Coming to content of this lecture. So first, introduction to universal gates. Then we have design of basic gates using the universal gates. In the designing of universal gates, we have NOT gate using the NAND gate, OR gate using the NAND gate, as well as that is basic gates, NOT, OR and AND using universal gate, that is a NAND gate, as well as same basic gate using of NOT gates. So firstly, if we consider the universal gates, so universal means universally we can design any logic function. So any logic function we can design using these universal gates. So there are two types of the universal logic gates, that is NAND gate and NOR gate. So these gates are essential for digital design due to cost and flexibility. So suppose if one circuit is there, so we have to use any logic function using basic gates, that is NOT gate, AND gate and OR gate. So if you are considering three different gates, so NOT gate IC, we have different ICs for NOT gate, AND gate and OR gate. So we have to use to implement the circuit with different ICs. So different ICs we have to use to implement. So instead of using different ICs, so maybe we will use, suppose if you are considering NOT gate contains, the NOT gate IC contains hex 6 NOT gates. If you are considering AND gate IC, so AND gate IC consider only 4 AND gates, and OR gate IC also consider having a 4 OR gates. So in that we may use maybe 1 or 2, or maybe we can use all the available gates, logic gates in the IC. So because of this, the circuit complexity is more. Circuit is complex. To reduce this complexity, so obviously if circuit is complex, the cost also increases. The cost to purchase NOT gate, AND gate and OR gate ICs. So cost is one factor as well as the complexity is one factor. So instead of these individual basic gates, if you are designing purely within using a NAND gate or NOR gate, universal gates, then cost will be reduced as well as circuit complexity will be reduced, as well as the circuit will be more flexible. So this is how we have to develop, we have to use these introduction to universal gates. Now coming back to NAND gate and NOR gate. So let us consider here one taking one. So here I am taking one new slide. So in the new slides I will write. So what is the universal gate and all, right? So first universal gate, NAND gate. Now if you are considering universal gate, NAND gate, so this having first I will explain about the logic expression. The logic expression. So we already know this NAND gate. In the last classes I have already told you NAND logic means NOT plus AND or AND plus NOT. So we know the AND logic, that is AB. If you are taking a NOR logic, that is a complement, then NOT, then we will get a NAND logic. So output expression is A dot B whole bar. So that is Y is equals to AB whole bar. If you are considering the logic operation, that is the truth table, so we have how many inputs? 2 inputs. Minimum of 2 inputs is required. Whenever 2 inputs are there, how many combinations we have? 2 power n, that is here 2 power 2, 4 combinations we have. 0, 0, 0, 1, 1, 0 and 1. Now we have the AND gate operation is end of these two inputs are 0 0 0 0 1 it is 0 1 0 it is 0 1 into 1 that is 1 1 into 1 that is 1. Now we have the complement of this. The complement of this will be AB whole bar. So 0 complement is 1, again 0 complement is 1, 0 complement 1, the 1 complement is 0. So this is the truth table for the NAND gate. So NAND gate truth table is AB, then we have output expression, that is AB bar. So 0 0 0 1 1 0 1 1 combination, we have 1 1 1 0. So we can say if at least one input of the NAND gate is logic 0, if at least one input of the NAND gate logic is 0, then output is definite 1. Right? So there we have to remember this thing to further proceed. Similarly, we have, let us take, so this is a NAND gate truth table. So we have already designed the NAND gate truth table is for 0 0. At least if at least one input is logic 0, the output is definite high. And now it will comes under, this is a NAND gate, this is a NAND gate logic, and this is a NOR gate logic. So NOR gate opposite to OR gate, opposite to OR gate. So NAND gate opposite to NOR gate. NOR gate is opposite to OR gate, right? So for OR, if at least one input is high, then definite output is high. Opposite to that is, if both the inputs are low, then output is high, and the remaining all the cases the output is low, right? So these are about the NOR gate. So let us consider one more slide I am considering here to explain you about the NOR gate operation. So NOR gate. NOR gate opposite to, so NOR, not plus OR. So we know the OR gate output expression y is equal to a plus b. So if you are considering the NOT, that is bar, then in terms of NAND gate, so AND gate complement. So first AND gate, then how many inputs we have? Two inputs, AB, the NOT gate. So this is a NAND gate circuit. So this NAND gate is, if you are adding bubble at the output of the NAND gate. So this is the NAND gate output expression, a NAND gate logic circuit. So AB whole bar, that is a output expression for the NAND. Similarly, if we are considering, if we are considering NOR gate, so this is a NOR gate logic expression. Coming to the circuit diagram, OR gate, so this is a OR gate, and adding NOT over here, the output of the OR gate. So this is OR plus NOT, right? So the a resultant NOR gate circuit diagram will be, so this is a NOR gate. So this bubble, whatever bubble we have, that we have to add at the output. So A and B is the input. The output of this NOR gate is A plus B whole bar. That is the output Y. So this is a circuit diagram. So circuit diagram for NOR gate. NOR gate circuit diagram. Right? So coming to truth table. So AB is the first I will consider OR gate, A plus B OR gate. Then I will add OR plus NOT complement to A plus B whole bar. Then that is the output for the my NOR gate. Now whenever I have two inputs, how many combinations I have? 4 combinations I have. Now A plus B, 0 plus 0, 0, 0 plus 1, 1, 1 plus 1, 1, 1 plus 0 is a 1. Right? So I can say if at least one input is high, then my output is definite high. Now complement of 0 is 1, complement of 1 is 0, again complement of 1 is 0, again complement of 1. So this is the overall, the output for NOR gate. So overall truth table I can write it down as y is equals to A plus B whole bar, then 0 0 0 1 1 0 1 1, and I have output 1 0, 0, 0. If I can say in terms of NOR gate as, if one or more inputs are high, if one or more inputs are high, the output is low. The output is low. So this is reverse, right? So this is a OR gate operation and this is a NOR gate operation. So these two are the universal gate. So through these universal gate, we can design any type of the circuit. Now let us have overall truth table for NAND gate and NOR gate. So NOR gate, this is one. For NOR gate, this is if one or more inputs are high, the output is 0. Correct? Now, the very first circuit is not using NAND gate, right? So how to get a NOT gate using the NAND gate? So first of all, we will take a NAND gate. So we will take a NAND gate. So here I am taking one more slide to explain briefly about not using NAND gate. So we know the that is this is our NOT gate. So NOT gate contains only one input. So this is if you are considering the NOT gate contains only one input. One input, one output. Suppose A is given, it will produce A1. Now I have to develop the NOT gate using the NAND gate. So how many inputs I have for NAND gate? So this is a NAND gate. So NAND gate is it contains two inputs. This is a NAND gate, right? So how to develop this NAND gate? One input I require, right? So suppose if I take a short circuit, that is shorting of these two inputs and given to single input, that is A, then it will generate the A. So let us consider the truth table for AND gate. What is truth table for AND gate? AB. So we have y is equals to AB whole bar. So in the expression itself, if input A is equals to input B, then I have y is equal to A dot A whole bar. So we know from the axioms of the Boolean expression, Boolean logic function. So A dot A always is A, that is A bar. A dot A is equals to A. So similarly, A dot A is equals to A, the complement, that is A bar, right? So 0, 0, 0, 1, 1, 0, 1, 1. So now what is the NAND gate output expression? 1, 1, 1, 0, right? See, if I equate A is equals to B, so A is equals to B, I will get 1, and A is equals to B, I will get 0, right? So if A is equals to B is equal to 0, then what is my output? My output is 1. That is complement of 0, that is 1. Suppose in the last case, if A is equals to B is equals to 1, the complement of 1 is 0, right? So this complement of 1 is 0. It means if A is equals to B, so both the inputs are connected to 0, then it is providing 1. If it is 1, it is providing 0. Hence it is proved. If I am combining these two inputs and giving as a single input, then this NAND gate will be act as a NOT gate. So here the NOT gate using NAND gate. So logic expression, first we are shorting these two inputs, giving to single input, then it will be act as a NOT gate, right? I think I am clear. Now let us move on to again Tinkercad. So here I will explain about the Tinkercad circuit. So go to the Tinkercad. So in the last classes I have already explained about how to uh, create a circuit, how to open a Tinkercad account and all. So here I have already account. So whenever I used to access that, it will directly open my account. So I will go to the Tinkercad circuit. Now I am opening a new circuit design to convert the NOT gate, that is to design. So this is my circuit, new circuit I need to design. So here I am changing the name for this circuit is NOT gate using NAND logic or NOT gate. Right. So first the main minimum component requirement is first breadboard. So here I have taken a breadboard. Then I have to give a power supply. So this power supply I am using. Then I need NAND gate. So let us consider the NAND gate IC. The NAND gate, quad NAND gate. So 7400 is the NAND gate IC. So let us place somewhere here the NAND gate IC. And here it is 1A, output 1B. So here two inputs, input 1A, input 1B, and output 1. So we have how many NAND gates? We have total for this IC, we have total 4 NAND gates, right? So I can use any one combination, either 1, 2, 3, 4, 5, 6. So 7th is always ground, 14th is always power. Then I can use 8, 9, 10. Then I can use 10, 11, 12, and 13. Alright. So total how many pins we have? I have 14 pins. Now let us consider, let us connect this positive. So positive. So in last classes I have already told you, positive always represented by which color? Red color. Now I have a negative circuit. So negative, connect this negative to the bottom line. So what is a negative color? Black color. Then I have first power VCC and connect the IC to the ground. So I cannot connect here, I have to connect here, right? So let us change this color, that is a red color. Now in the previous what I did, I have shorted the two inputs with a single wire, right? In the same way, so here I am taking two inputs. So to check the output input, I require one resistor. So resistor I am taking here and one LED. So LED will positive anode has to be connected to the resistor positive terminal and negative terminal has to be connected to ground. So cathode has to be connected to ground. So I have connected, right? Now what is a resistor? Second terminal has to be connected to output, right? Now what I am doing? First I am considering 1, 2, 3 pin. Okay. So first start these two input lines with a single wire. So here I have used green color. So what is this green color indicating? I have shorted two inputs and given two single output, right? So to give a single output, we require again switch. Whether you can consider the dip switch or you can consider the SPST switch. This switch we are using. Alright. So we know how to connect this switch also. So first 1A has to be connected to the VCC. 1A has to be connected to VCC. And what is my output? 1B is my output. So here how many outputs, how many inputs I have required? I require only single input. Right. Now connect this single input to any one particular pin. Either you can connect here or you can connect here. So this green color. So I am connecting somewhere here. So let us change this input color as a blue color, right? So remember this blue color is input, single input I have given. I have shorted 1A and 1B with a green color. Where is my output is available? My output is available at this pin number 3. And this is my output. So this output I have to connect it to second terminal of the resistor. So I have, in order to make a difference, so purple color I have given. So 3 different colors I have given. So first different color, that is an input. Second different color, that is shorting both the inputs. And next purple color I have given for connecting the output connecting to terminal resistor, right? So here I have connected all the things. Now let us start a simulation. If you are starting the simulation, see where is my switch? Switch is available in the off position. If it is off, LED is on, right? So if it is off, so let us consider, it is on, the switch is on, it is in off position. So this is how you have to perform. You have to be connected this convert this NOT gate connection using the NAND gate. So hereafter, so whenever we have a NAND NOT gate, so NOT gate, how it is available? How it is by shorting two inputs of the NAND gate and giving to single input. Then the output of the circuit will be act as a NOT gate, right? So when it is, if switch is on, then the LED is off. If switch is in off position, the LED is in on position, right? So I can write it down here as note. To make a changes, you have to first stop the simulation, then only it will come, right? When input and output. If input is 0, the output is the output is 1. If input is 1, the output is 0. Hence satisfied. So this is how to perform, how to convert NOT gate using the NAND gate. Now it is same for NOR gate also. So let us consider, instead of NOR gate we can take a NOR gate, right? So firstly I will explain about same one more slide I will take. In the same way, how to convert the NOT gate or using a NOR gate. So same, this is a NOR gate. NOR gate contains how many inputs? 2 inputs. So same way we have connected to NAND gate, right? So AB. So this is A bar. That is a NOT gate. Now same way we will consider this is a plus B full bar, right? Suppose if I short two inputs and giving to single output, it means same, A is equals to B. If it is A is equals to B, then again it will be act as a NOT gate, right? So A plus A whole bar. We know A plus A is equal to A. So A bar. So this is the output expression for same as the NOT gate, right? So in terms of truth table also will explain. So AB for NOR gate 0 0 0 1 1 0 1, right? For NOR gate it is 1, remaining all the cases it is 0. Okay, so this is A plus B whole bar. Now if I take A plus A, that is, see, A is equals to B. If I given two inputs, shorten two inputs, A plus B, it is 0 plus 0, that is 1. In the last case, 1 plus 1, 1 plus 1 NOT gate, that is, if both the inputs are 1, the output is 0. It means if A is equals to B, that is 0. What is the output we have to get at the NOT gate? NOT gate output should be 1. If A is equals to B, that is equals to 1, the output should get a 0, right? So this is a NOT gate operation. So it is same for either it is a NAND gate or NOT gate connection using the NAND gate or NOT gate connection using the NOR gate, right? So same I will explain about. So here I will take, sorry. So let us move on. So we will take NOR gate. So quad NOR gate 74. Okay. So here I am considering one more breadboard. So here itself I can provide, but it will take clumsy of the circuit, right? So same, I am considering this NOR gate. So I have already told you NOR gate is little different based on remaining circuits. So first pin is output, remaining pins are two inputs. Again, our third pin is fourth pin is output, remaining two pins are the inputs, right? Alright, so here I can click on. Then I have same resistor. So let us take a resistor. Then I have an LED. Let us take an LED. So change the color of the LED is an orange. Orange. Now we need a power supply. So connect this power supply. Connect this positive terminal to here. So connect the negative terminal to the so change the color, it is as a red color, same. Now what I have to consider? I have to consider, I'm considering one switch, SPST switch. So connect this 1A terminal to VCC, and second is my input, right? Now what I have to do, this is an output. So let us consider these are two inputs and this is an output. Again this is output. So here we have ground, connect this to ground, connect the IC to the power supply, change the color as well. Then first 1A and 1B, right? So short these two inputs with a different color, green color. Then give this input, connect this input to any one of the input line. Either 1A you can connect or 1B you can connect. So I am connecting here 1B. So any one terminal you can connect as an input. So change the color. Then where is my output is available? My output is available at pin number 1, right? So connect this pin number 1 to the resistor first terminal and change the color it as purple color, right? Now we have missed one connection. Connect this cathode to this ground, change the color as well. Now I have the overall circuit. If I start the simulation, see, even though it is in off position, the LED is glowing. So, suppose if I click on the switch, it is in off position. In both the cases I can see, so we have NAND as well as NOR. If both are on, the switch is LED is on when switch is in off position. Suppose if switch is in on position, then I got the off position of the LED. Alright, so this is how we have to convert. We have to convert any NOT gate, or we can NAND gate using conversion for NOT gate. Right. So this is how we have to perform the conversions operations. Okay. So in the next class, we'll discuss about how to stop simulation. Stop simulation. So here we have discussed about first universal gates, how many universal gates we have. Then we have content. So first the topic NOT gate using NAND gate we have covered, as well as NOT gate using the NOT gate. Right. So these two topics we have covered in this PPT, in this lecture. So first, how many NAND gates are there? Two universal. How many universal gates are there? Two universal gates. Why it is used? That is flexibility and cost effective. Then we have the definition for NAND gate. That is a basic logic expression, circuit diagram, what is the truth table for the NAND gate we have learned. Thereafter we have learned about the NOR gate, how it is NOR gate, what is the logic symbol and circuit diagram for the NOR gate, how the NOR gate truth table is. Right? Then we have learned the NOR gate using NAND gate. So by shorting the two input lines, connecting to the single input. So we have already practiced with the Tinkercad simulation also. Alright. So this is an NOT gate. How to convert basic gate NOT gate using the NAND gate. Right. So NOT gate also we have covered in this class. In the next class, we will learn about how to convert AND gate, how to design AND gate using the NAND gate, as well as AND gate from the NOR gate. So one more basic gate, that is the OR gate. How to design OR gate from the NOR gate as well as NAND gate we will learn. Thank you. Thank you so much for learning this course. Thank you.